Hey teachers, today what we're going to do is walk through an activity that we've written that allows students to understand an application of linear relationships, linear equations, and this application is the idea of opportunity cost. What we're going to do is walk through a hypothetical budget constraint for a consumer. And we'll just use, like I said, we'll use linear equations to illustrate that relationship. So what we're going to do is use this idea of a budget constraint to show that linear equations can be used to illustrate the trade-offs that are involved in making consumption decisions. As far as common core goals, these are the goals that you're going to be hitting with this activity. And in terms of economic concepts, we're going to be talking about opportunity costs, something students should already be familiar with from their work with order of operations and compound interest. The idea of a budget constraint, and how am I get these resources, how am I going to allocate those resources? So these are the three economic concepts that are going to be illustrated with this linear equations application. In terms of the CITME progression, right, this is a personal finance progression, and this is definitely something that that students will build upon in the personal finance section on their way to entrepreneurial and global thinking. So let's start with a story here. We've got a typical teenage kid named Adam. Adam's a consumer. He's got an income of N dollars per month. Maybe this is an allowance. Maybe this is something he gets from working a part-time job or whatever the story is. But he has $40 a month that he can spend. And he likes to spend his money on two different things. All right? He can either go out for food at a restaurant. Maybe he does that with friends. Or he can go to a movie. Right? And Adam... what we're going to try to do is show Adam's ability to consume these two goods given his income. And we're going to start off by using a standard form linear equation. AX plus BY equals C, and illustrate that Adam wants to spend all of his resources to make himself as well off as possible. So in Adam's world, there's three things that he has to worry about in order to construct this budget constraint. Right? He's got to worry about the price of food, he's got to worry about the price of a movie, and he needs to know what his income is. Once he has those variables, then he can make a decision about how much he would like to consume in terms of food or movies. So let's just say straight off that the price of food is $10 per meal. So if he goes out with his friends, he's going to spend about $10 per meal. If he goes to a movie, right, we're going to illustrate that with P sub M. He's going to spend $8 per ticket, and his income is $40 per month. So these are the three variables that Adam's going to work with, and he's going to make a decision based upon his preferences for consuming food or movies as to how many of each of those goods he's going to consume. And the one thing that we have to get across to students here is that Adam has a limited amount of resources, and in order to make himself as well off as possible, we're going to assume that Adam wants to consume all of these resources. And the reason is there's no credit market. Adam can't save his money for a rainy day. He can't earn interest on unspent resources, on unspent income. And so what he's going to do is just spend it all. So he's going to locate himself, as we'll see later, somewhere on his budget constraint. And in order to figure out how much of his resources he's going to spend on food and movies, we need to come up with terms that illustrate this, right? So how much is he going to spend on food, right? That's going to be the amount spent on food, plus the amount that he's going to spend on movies. Those two are going to have to sum to his income. If they don't sum to his income, then he's not making himself as well off as possible. Obviously, he can't spend past his income because there's no credit market and he doesn't have an ability to borrow. So it has to be the case that the amount that he spends on food plus the amount that he spends on movies equals his income. So with regards to movie expenditures, right, we're going to say that M is going to be the number of movies that he chooses to attend. And the price of those movies, as I said earlier, is $8 per movie. Right? And we want to come up with a term that tells us how much he's going to spend on movies. And the amount that he's going to spend on movies is just going to be the product of the price of movies multiplied by M, the number of movies he chooses to attend. And because we know that the price of a movie is $8 per ticket, right, we can just say that the amount that he's going to spend on movie tickets is $8 times M. And then similarly for food, right, the price of food is $10 per unit. If we multiply that by F, the number of units of food that he's going to choose to consume, then we get the amount that he's going to spend on food. That's just going to be $10 times F, given the current prices we have for food. So if we sum those two things together, right, if we sum the amount that he spends on movies plus the amount that he spends on food together, we should get $40. And in general, right, that takes on that AX plus BY equals C form. AX plus BY equals C. So you can see this budget constraint that we've constructed is in standard form. Now let's change this around to slope-intercept form, because students, math students at this level need to be able to go from one to the other. And the slope-intercept form, right, we're going to solve for M, although we could solve for F too. There's no dependent or independent variable here. They're variables that are traded off with each other. If we solve for M, then our slope-intercept form becomes M equals negative 5/4 F plus 5, right? And in general, right, we get negative 5/4 from the ratio of the prices of each of the goods. So now we've got this in two forms, standard form and slope-intercept form. And so let's take a look at graphing these things, right? So it doesn't matter. Obviously, there's no independent or dependent variable. Let's graph the number of movies that Adam's going to attend on the y-axis and the quantity of food he purchases on the x-axis. Right, so our graph is going to have movies up here, food down here. And the first thing that I like to do when I graph these is find the intercepts. Right? We're just going to connect the intercepts. So if we can find the intercepts, then we have a really easy job of just connecting the two dots. If Adam spends all his money on buying food, right, then that's symbolically, that's what's going on with finding an intercept. He's not going to buy any movie tickets. So we can use the budget constraint that we constructed earlier. We can substitute M equals 0 into that standard form budget constraint and come up with F equals 4. So if he's not going to go to any movies, he can have 4 units of food. Similarly, if we do the same thing where he doesn't buy any food and he chooses to spend all of his money on movies, then he can go to 5 movies. Right, so if we graph these budget constraints, the intercept for the movie axis is 5, and then the intercept for the food axis is 4. And then obviously this is a linear budget constraint, it's a line, and so we just connect the intercepts. And now what we've done here, and this is important that students understand that, is that we've traced the possible number of food and movies that Adam can buy. Right? That tells us how well off Adam can be given his income and the prices that he faces for the two goods. Now I'm going to stop right here and I'm going to pick up and we're going to talk about opportunity cost in the next video.